What's happening, guys? Welcome back to the Motorcycle Garage. We've got some exciting things to show you today, so stick around, it should be a good episode. So, anyone who knows me from my first bike, seen in the background, knows that that was a great starter bike. It taught me a hell of a lot, but I want to do things a little bit differently for this bike. I want to push the extent of my skills a lot more, from a design point of view, from a fabrication point of view, pick up skills along the way and hopefully share them with you to help maybe inspire you or just simply give you some stuff to watch and enjoy. So one of those bits was, right, how can I make this bike different? How can I make it so it's not just someone's rolled it into the motor gadget shop and come out with all their offerings and me 1.5 grand poorer. I didn't really want to do that. I wanted to kind of push the boundaries of my own skills to say, well, can I develop my own indicators? Can I develop my own switch gear? Can I develop my own yokes? And yokes, for me, yes, you can buy yokes. They're bloody expensive custom yokes, but also when you look at them, are they actually that complex? Yes, they serve a really important part of your bike, and if they get it wrong and they break under a fatigue load or whatever, and your fork decides to fall off and you crash and die, that's obviously not a good thing, but you can design your own yokes. And that led me down the path of, fairly early on into this build, can I maybe get some yokes made for this? So to share a bit of background, see on the screen here is some CAD again. Woohoo! If anyone who watched my CAD video last time will know that I've been picking up my CAD skills again to try and get better at these builds and try and use the knowledge and skills I do have to help push the boundaries of the skills that I don't have. So I designed a set of yokes on CAD, and I just kind of let them sit for a while. I went off them a little bit. I went cold with the whole idea, purely because maybe from an expense point of view, maybe because I was trying to throw so much at this bike, and then I thought, what the hell else am I doing? We're stuck in lockdown. We're this never-ending hell that is, you can't do anything other than go out to your garage. Oh no, what a shame. However, so anyone who watched another one of my more recent episodes know that I've used 3D printing quite extensively, and this is the front panel that I've designed for my bike. So this front, try not to fall. This front panel is to go on the bike itself. So I've redesigned this a little bit and whatnot, so this is due another iteration very, very soon. However, when we've got this nice clean looking front panel, one thing that sticks out like a sore thumb is these but ugly yokes. And that was initially my reasoning for designing my own yokes. However, after seeing this in place, it quickly got me thinking, you know what, these yokes, I should probably actually go ahead and build these yokes. A, because it's a cool engineering project. I've got a design. What more do I need? What can I do to make these yokes mine? How do I go through the process of making sure these yokes work? How do I go through the process of getting them manufactured? And to be honest, yes, if they manufacture and they're nice and they fit directly on to a bog standard XS850, XS750 front end, and people don't think they're minging, then maybe I'll sell them as well. But for me, this is just right, we've got yokes, we've got a yoke design, how do we progress that to the next stage? So, let's head over to the workbench, which is actually only one step away. I don't know why I made it seem as though it was. So, yoke design's not really complex, but it's not that straightforward either. You have to take a lot of measurements off the original design. So, the stanchion diameter, stanchion spacing, how it links up to the main stem bearing, the size of the main stem and everything else. And I'm not saying I've completed this by any means. You pick this up at a point where I'm in the design process of this build. I've got an idea, I've got a rough idea on CAD. How do we take that to the next level and extrapolate from that? So fairly early on in the year I was able to get all those dimensions, sketch them in my book. I think I'm pretty sure I've got a sketch here in my book. But whatever, I was able to take the sketch dimensions and then transfer them onto CAD. And I went through a few different iterations of yokes as well, and I've ended up landing on a design that's kind of, I don't know, it's unusual. I've not seen a design like that before on yokes. It's quite modern looking. Sorry, my hair's pissing me off. So when I was back down the road at Christmas time, I asked my dad nicely if we could use a 3D printer and we could get a yoke made. So Ta-da! This yoke here was printed in the 3D printer. Obviously, it has. It took a hell of a long time. It took like 11 hours, but I think that's actually quick in comparison for something this size. And due to the shape of it, it had to be printed vertically because it was too wide to fit on the body, the print area of the 3D printer printing area. So we had to print it on its back. So all the holes are full with support material so that you could build. So when you print in layers, and it goes. So it goes backwards and forwards, and it starts to build up one layer at a time. I can't remember what the interval was, but it was a small interval. So it starts to build it up. So to build these bits on the top, you have to put infill material in here so that the thing it has something to print on. It doesn't just want to collapse in on itself. So that's why all these holes are full. Fill my hole. So the next thing we need to do is get rid of these holes and then trial fit it on the bike. So like I say, this has been 7 minutes of me chatting shite purely to tell you that we need to get rid of these holes and get this thing on the bike. I should really get better at talking. Anyway, so plan for this is to get rid of, there's a little base here, I can't remember, my dad told me what it was, but it needs to come off. Essentially it just allows the 3D body to blah 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 blah, blah, and then magic happens and then it 3D prints. So this isn't full, this is like 10 or 15% infill, so it's not rigid, it's rigid, but it's not properly, it's not a solid piece. It's like a honeycomb if you want to imagine it that way. So some flex in it, not a huge amount of flex. So, but I'm not going to be bashing this thing down with a hammer to try and get it on. So let's use everything we have at our disposal. We've got a knife here to cut this fill material. Got some pliers, got a drill. We need to really get all this stuff out. Then we'll take it over to the bike. So we'll catch up with you in a little bit. Broke the tip off. I keep breaking the tip off things. I don't know if this is going to cut it. No, literally. This is shit. Oh, for fuck's sake. This is just to give it structural rigidity. It didn't crack it. Honest. Bollocks. Really got the best patience, maybe, and so I ended up maybe breaking that slightly. Where's it going? Yes, that thing clamped together with super glue. So in an ideal world, we would have printed it on its back, therefore none of this infill material would have been needed. However, also more care and attention would probably have been a good idea. So once we're like that set, we're going to take the yoke off and we're just going to slide it over and see how it fits. I think it will fit okay, but it'd be quite exciting to just get it on the bike and see what it looks like. A few things to note of this. This is only the top yoke. I need to design the bottom yoke, so there's a few things outstanding with that, which is the stem size, interference, fits and everything else. How do we make sure the stem's mounted, and do we weld it on? Do we not need to weld it on? These are all questions I don't really know the answer to. One other thing as well was with something like a part like that, it's designed in CAD. I've used the existing one as an offset, I guess. So with that, I'm just going to turn this fan off because it's quite loud. With that, do we need to do things like finite element analysis, i.e. what they run on designs, computer software simulations under various loads to simulate real life conditions to see how the bit performs. So I'm planning on getting this milled out of aluminium, 6061 or whatever grade of aluminium that I can get made. So this is, yeah, sorry, I don't know if I've mentioned this. This is purely for prototyping. I hope no one's watching this thinking this moron's gonna use this bit of plastic on his bike. Other bits, yes, but not something as fundamental as this. This is clearly a prototype that will then help me decide that yes, my dimensions and everything are right before I pull the trigger and get machining done, which can be quite expensive, and I've not got a quote for it yet, and I'll probably get a nasty shock when I do, but in for a penny, in for a pound. Anyway, so yes, I want to run finite element analysis on this. I don't really know what inputs to use, like what kind of load does a stanchion see, what kind of load does a yoke see throughout daily use. With something that's shaped like this, there's no sharp corners on it, but you don't want sharp corners. They can act as stress concentrators and everything else, but I don't really know how that's going to react because there's more angles in it than would be, say, the original one or some of the other ones that you can maybe buy as an aftermarket. I don't think that's a bad thing. I don't think that the forces that are going to go into this are significant, but I would like to, for the nerd inside of me, I'd like to see whether I can run a finite element analysis simulation on it. So if anyone knows anyone that's done one of these and ran such a simulation, then let me know in the comments below, or just, yeah, throw some ideas at me, because that will be the next stage. So now that this is just about set, we'll get the top yoke stripped off the bike, and then we'll line this up and see how we get on. I don't know how this is going to go. This might break. Here's something interesting. Okay, so you find me at a point where I'd filmed a second part of that video which explained how much of a gigantic retard I am, but in reality I wasn't as dumb as I thought, and I've decided to fire up the CAD, and hello Brian, fire up the CAD and kind of show you what's gone wrong, pretty much. So once this cat gets off me, excuse me boy, and I figure out how to record this video again, But essentially what's happened is, yes, my yokes are wrong. They're not, the spacing between them is wrong, but everything that I've measured up until that point has been correct. So the yoke spacing is 150mm between the inside edge of each of the stanchions, which I've taken up from the original model and from the one I was measuring off, and for the drawing that I had. And then for whatever reason, when I've gone through various iterations on CAD, it's changed. So if we look on CAD, the way I've drawn this is like in half, and then I've done a mirror, so I've assumed half of it. And the way you can do a lot of CADs is you can have fixed spaces and fixed length and constraints. So I have now corrected this, but what had gone wrong was I'd made the distance between the outside and the centre of the stanchion a fixed distance, where in reality I should have made the space between this edge of the stanchion and the midpoint a fixed, which would be a 75mm, so when we double it's 150mm. So for whatever reason it's not worked out. I know I'm a retard, but I'm going to take this opportunity to try and, I think there's a way to reprint this that I don't have all the filler material in it. I think there is a way that you can maximise greater than whatever the print area is, the stated print area is for the 3D printing. And then similarly, I guess if we go back to the CAD, excuse me boy, oh God, this cat. Go back to an older version, always save, which is something I don't do. Right, if we go back to this older version on the screen, you can see there's bits here, right, which is what I planned to bolt this thing together with. This is a threaded boss all the way through here and a threaded boss all the way through this part. However, not knowing, I've never done any milling, but I don't think that's going to be the easiest to get a tool in there to drill that hole and cut that bit out. So in reality, I think what I will do is swap, and also this is actually quite thin. If you look at this edge here, edging, get off this. If you look at this edge here between the yoke, the end of the yoke, I'm trying to get a, if you look at this area here, it's not very big, and this area isn't very big. Now I've not run any finite element analysis on this, therefore I don't know, is that too thin or not? You look at some other yokes and they've got quite thin, but right now that's 7mm, and to me, based off nothing other than pulling a figure at my arse, I think 1 centimetre, 10mm would actually be better thickness. Which again pushes me outside the print boundary potentially. But so I'm thinking, when I look at this, I will increase this slightly, and then I'll also rejig it so that these holes are no longer there. Yeah, we'll rejig it so those holes are no longer there, and then they get bolted in from the outside. So I just move the bolting area onto the outside with a recess in it and a threaded hole on the inside, so that if I've got a recessed area that the head of the bolt can squeeze tightly and pull together, then that will be quite nice. Looking at this, it's not that complicated. I don't know. I'm looking at it and saying, I've never used a mill before, but I know someone that's got one, and I think we could potentially maybe look at something that we could mill this. I've just watched a really good YouTube video of someone who's done exactly the same. I'll get a quote first, see how much it is. If the quote turns out being quite reasonable, then that should be okay, but if not, then there's potentially an option there to mill something like this. So this is how I wanted to finish the video. Unfortunately, I'd had a huge spiel still in my garage about what I think had gone wrong. In reality, I have made a mismeasurement, but I've not made a mismeasurement. I've measured everything correctly, but when transferring the model to CAD and going through the various iterations of the CAD model, for some reason I've lost that constraint that has that fixed length, and I've never checked it again afterwards. So frustrating. Now the model's set up so that constraint's in there. We'll get another one printed. Dad, please. Get another one printed, and then I'll hopefully get my face plate printed again. I had some really helpful comments and just some good feedback on my last video with people with some suggestions, so appreciate those comments. I will make a version of it and have a look and see what we think. I might even try and just spend a little bit more time modelling that, excuse me please sir, modelling that so that if I think about how I'm going to be sticking the lights to the inside of that or mounting that to the inside of the lights that I eventually get, then it maybe means I have to go through one less iteration of printing. So, so next video we'll probably be doing stuff back in the garage, focusing on the exhaust, that bit pain in the ass area of trying to get the exhaust lined up, and I've been thinking quite a lot, so I've got a good few ideas for that. So that'll be the next video. Hopefully you enjoyed this. If so, please like, subscribe, follow me on Instagram, send me a message. It's always good. Let me know what you're working on. I really enjoy people that follow me and tell me they've got projects. So I can go and have a look at them and see what other people are doing. So take it easy, guys. Have a good 2021. We're in the new year now, and my so dry January is going really, really well. So until then, see you later, guys. Take it easy.